Of our discussion for our chapter 2, and we are going to tackle the use of the arithmetic gradient factors and the geometric gradient formula in this discussion. So, in sometimes the cash flows that occur in consecutive interest periods are not the same amount or not the value of annuities, or that they are not uniform, but they do change in a predictable way. So these cash flows are known as gradients, and there are two types, the arithmetic and the geometric gradients. So first we will discuss about the arithmetic gradient. What you're seeing now is an example of the conventional arithmetic gradient series without a base amount. So here is the gradient. So there is a uniform increase of the gradients per period from G to 2G to 3G, 4G, and so on and so forth until it reaches n minus 2 times G and n minus 1 times G as it reaches n period. So the equation that represents the present worth of an arithmetic gradient is this formula. P is equal to G over I quantity 1 plus I raised to n minus 1 over I quantity 1 plus I raised to n minus n over 1 plus I raised to n. So this is the equation that represents the present worth of the arithmetic gradient. So, for example, there is a base amount and then there's an uniform increase in the base amount we call as gradient amount here. So we have here the base amount in this portion, and then we have here the gradient amount, and that starts from year 2 or period 2. So if we going to find the present worth of the arithmetic gradient cash flow series, so we have the formula P is equal to the present worth of the base amount here, the present worth of the base amount, and the present worth of the gradient amount in this one area, or is equal to A quantity P over A I percent N plus G quantity P over G I percent N, where A is the amount in period 1, and then G is the amount of change in cash flows between period 1 and 2, and this portion is the G, and then N is the number of periods from 1 through N in the gradient cash flow. So this portion, and I is the interest rate. And then, so if the gradient cash flow decreases from one period to the next, the only change in the general equation is that the plus sign becomes the minus sign. So this one becomes a minus sign when the gradient flow is in decreasing order. And then now we go to the present part of the geometric gradient series. So the same discussion is similar to arithmetic gradient. And then for the geometric gradient series, the difference is that the increasing or the gradient of the series. So there are two conditions. If the interest is not equal to the gradient, then we will use this formula. On the other hand, if the interest is equal to the gradient, then we will use this formula. And then this is the factor notation for a geometric gradient. So we can say that this is an increasing gradient, and then this is an decreasing gradient for geometric gradient series. And then in the next videos, I'll be showing to you some examples on the use of arithmetic gradient and geometric gradient. So I hope that you find something new in this presentation. Thank you.